Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we will take a look at 2021 Fall AMC 10B number 12. It asks, which of the following conditions is sufficient to guarantee that this XYZ basically satisfies the equation this? Well, looking at this, we really don't have an easy way to factor this. Let's say we might be able to get it in the form of x plus y plus z and times something, but you have to subtract something out of it, and it's minus, so really couldn't do anything with it. And that is the reason why even after that kind of investigation from everyone after the test, there really isn't a better strategy than just plugging the answer choice in. And in my opinion, this question is poorly written, but we will just take a look. It says x is larger than y and y is equal to z. So if y is equal to z, then y minus z, that will be equal to 0. And z minus x, let's take a look. X times x minus y plus z times z minus x. We know that y is equal to z, so x squared minus xy plus y squared, that minus xy, because we know that y is equal to z, and if we take a look at it, there really isn't anything that we can cancel out, so that will be it. And we know that A just does not guarantee you this equation be satisfied. Let's now take a look at B. B says x is equal to y minus 1 and y is equal to z minus 1. If x is equal to x, then y is equal to x plus 1. So x plus 1, and z is equal to, that will be z, y plus 1. So y plus 1, so x plus 1 plus 1, so it's x plus 2. If we plug those in, we get x minus y. So x minus y is just negative 1 plus this y times y minus z. Y minus z, the smaller minus the larger one, so y minus z is just negative 1. And I realized that there is a type, just wrote it wrong. X times negative 1 times y plus y times negative 1 plus 2z. Because z minus x, that is equal to 2. And that is equal to negative x plus, or minus y plus 2z. And this gives negative x minus 1 plus 2x plus 4. If we cross all those, we see that this is indeed equals 3, but the equation wants it to equal to 1. So that does not satisfy either. So this is not our solution either. X is equal to z plus 1, so z is equal to x minus 1 basically. We get x minus 1, and y is equal to x plus 1. So if y is equal to x plus 1, then that will be x plus 1. If we plug that into our answer choice, we get x times x minus y. Well, x minus y, that is just going to be negative 1 because x is smaller, if you recall. Plus y times y minus z. So that will be x plus 1 minus x minus 1. That cancel out, we get 2. So y times 2 and plus z minus x. Z is smaller, so that will be negative 1. So that would give us x, or negative x, plus 2y, but y is x plus 1, and minus z is x minus 1. So that gives us negative x plus 2x plus 2, minus x plus 1. That indeed gives us 3 again, which is not what we are looking for, because we are looking for 1. So C is not the answer choice either. Now D, x is equal to z and y minus 1 is equal to x. So if x is equal to z, then we'll get xx. And y minus 1 is equal to x, we get y is equal to x plus 1. So that will be x plus 1. And the expression itself will give us x times x minus y, that will be negative 1, plus y times, so x plus 1 times y minus z, that will just be 1, plus z times z minus x. So z is just x, z minus x, that will give us 0. So that term just completely cancels out. You get negative x plus 1, which gives us 1. So we know that D is indeed guarantees that equation to be true. You can just choose D during the natural AMC, but just making sure, we'll try out E. So if we have x plus y plus z is equal to 1, that is actually tough because everything else gives us basically 2 requirements, but this one just basically only gives us 1. X times this plus y, or y minus z plus z minus x. You see that you really cannot simplify this expression a lot. The most you can say, oh, I have 2 equations, but I have 3 variables, which means that this definitely is not solvable. So E is not our answer choice either. Therefore, our final answer choice will be D, but just as I said, there's not really a good way to do it other than just plug every single answer choice in. Thank you for watching this episode of Interstigation, and I will see you in the next one. And if you're watching this just before Christmas or during Christmas, Merry Christmas to you, and I will head out. Goodbye.